Hope you hear me properly. So, good morning again. Today we continue topic related to medical informatics and biostatistics. Right now, I'm going to finalize materials related to topic 4, in fact, which is about biostatistics, hypothesis testing, and right now I'm going to consider question related to correlational, regressional analysis, and provide some introduction into optimal management problem solving, and then we move into actual topic 5. As usually, your capability for interaction is limited, but lecture as well recorded. So in case of question, provide the chat. Okay, let's move into lecture. So previous time I finished on hypothesis testing a question, provide overview of it, and right now we continue with other kind of possible type of analysis. And let's start with relational analysis at this point. So in fact, correlation is statistical techniques that can show us whether and how strongly pairs of variables are related. So it's give for us insight about kind of presence permanent relationship between variables. Measures for this relationship is coefficient of correlation, labeled with R, could be range from -1 to +1, which reflect ideal negative or ideal positive correlation. And definitely so close R is to minus or +1, that's more close to variables are related. So it's very common mistake when students spoken that -1 is no correlation. No, it's fine, very high negative correlation. So absence of correlation, its value about 0. Also, as additional measure, we use a square coefficient of determination, which show percentage of variation in y variable, which is explained by all x variables together. In general, if you look about the following flowchart of statistical test, which is widely used in various areas, so here is given place of correlation, which is dependent, and we have few methods for estimating of correlation relationship depending to amount of variables and data types. As you can see within this chart, there are also present mentioned hypothesis testing method, which I have demonstrated previous time. So previous class, I provided more simplified chart, which helps with identification of hypothesis testing, which is a method for statistical analysis. And here is more general version of like kind of cheat sheet, which could help you with identification of proper method for conducting statistical analysis, depending of what kind of data you have, again, dependent of type of data for dependent, independent variables, relationship type, and so on. So here is, I strongly recommend for you to take notes from this or take it from presentation, this slide. So, and as you have seen from previous slide, we have two main type of correlation coefficient dependent to distribution type. Pearson product moment correlation used when variables are normally distributed, and Spearman rank coefficient correlation repeated when variables skewed or ordinal, and it's robust when extreme values are present as well. So if we have deviation from normal distribution, or our data is not discrete but ordinal by type, quality. So this case, Spearman's run correlation had to be used. In fact, both of this equation here is given both of this equation for Pearson coefficient correlation, Spearman coefficient correlation, and as well proposed one of the approach how to identify see how strong correlation is. And finally, we have to use also critical value for Pearson and Spearman coefficient correlation, and depending to sample size to ensure that our correlation not only have some given power, but also have some reliability in our result. If we are talking about practical solution, so again, as usually, I'm starting with using spreadsheet as more simple and widely used application, and definitely it support Corel function, which implement Pearson product moment correlation. So if you have if your data not fall into normal distribution, you have to calculate ranks and implement Spearman correlation semi-manually, I mean by functions. And here is shown example fine case with ideal positive negative correlation, how they look like. So two variables follow each other in positive correlation and they are opposed, mirrored in negative correlation. In addition to this, Excel support tool called correlational analysis under data analysis toolpack, which just very useful in case if we have multiply variables and try to got all possible pair correlations. So here is given a result like this one. And if about live example, I can provide it. Here is we have like two variables and we want to identify possible relationship between these variables. So in case I'm not deep into practical meaning of it, what this data represent, or we have like two measures from our get two samples from our population which represent some little parameters. So here is if you want to just got simple correlation between, sorry. Just pick up Corel function, provide the two arguments, first array and second array. Here is we have our value of coefficient of correlation, which is moderate negative correlation. In fact, it could be confirmed, visualized if you draw conventional line chart, which will depict behavior of each variable. But if you want to visually depict correlation, it's definitely much better to use another type of chart, XY scatter plot, which is give for you, in this case, the only correct way to use this type of scatter plot, and it's produce for you direct relationship between X and Y. And for sure, if you want to identify, for example, a maintained coefficient of determination, so you have to add linear thread line and display a square value, and here is it will be. So here is we have a line which depicts ideal correlation between two variables, and here is a level of determination which is given here. As you can see, pretty easy. Same way you can use, for example, analysis toolpack with correlational tool, which give for you ability. So as I already said, it's mostly better to use it when you have when you want to calculate correlationship for multiply variables, because in this case you just get exactly the same value like from previous case. So we have moderate negative correlation. Okay, get back to our questions and move into second point of next one point, actually third point of topic 4, which is related to cover fitting, or more general regressional analysis, which is a set of statistical methods used to estimation of relationship between dependent variable and one of more independent variable. So here is, it's like sounds similar to previous identification relationship between variables with correlation, but in this case, first of all, we could have more than one independent variable which affect dependent. And what is more important, what it will be produced with regressional analysis. We want to identify some permanent relationship, and it will be provided and confirmed with modeling that we have to retrieve as a result of regressional analysis. So when in a correlational assessment, we, let's say, only one measure which give for us answer, is it variables related or not, regressional analysis give us the mathematical model which could be used in further investigations. And one of the techniques that's curve fit into this process of trying to find curve or line, or which represents some, again, mathematical equation, unlike our numerical data set, which best represents sample data. And it actually reflects the relationship between independent dependent variable in data set. So where is our actual data represent our random fluctuation? When we approximate it with curve fitting, we looking for some general standard mathematical model, or which looks like very similar to our case. And then just I have to remind you about most common mathematical model, which include linear equation, logarithmic equation. So since you had learned in school on the math classes, same power, exponential formula, and polynomial, which include equation like this one, and could have multiply stages, so there are 6 power, it's not limitation, it's just this example. So in fact, again, spreadsheet will support these techniques initially. For sure, if you want to perform advanced analysis, it's better to use something more specially designated for regressional analysis, special software like R, statistical, etc. But for initial assessment, spreadsheet it's still a very good tool. You can use analytical approximation with forecast and logarithmic functions. You also can use curve fitting with to nonlinear approximation, and listed before models supported by spreadsheet. So again, you can add scatter plot, add trend line, and Excel will produce for you model equation which will reflect model which as fit your data as best as possible. Here is given a recipe about how to add trend line, which is I already demonstrate with one example, which is related to correlation as well. And here is a practical example we can add. For example, it might be like some observation of occurrences, some event during the time. For example, it's usually used with time series analysis. And here is given example how to add order 3 polynomial trend line and provide immediate forecasting for future development next 2 months in this case, and also visualize model and equation of model and coefficient of determination, which in this case depict reliability of this model and provide also assessment how about its quality, how good it fit our experimental data. So here is settings which is necessary to do. And the usual example would look like this one, where you have your data series depicted, and you add various different trend line with models and equations, so you can make the assessment which one is best fit your data. In this particular case, it will be definitely linear model, and next will be power. So, okay. And if it's, we will move again into live example. Let me show this same data set. So here is very usual applications, for example, in epidemiological studies to determine a number of occurrences of some kinds of infectional diseases within next period when we have outbreak of any epidemic or pandemic. So practically in classes we will deal with COVID data, and here is I use like numeric data from even previous example, but under different circumstances. So here is I consider it's like number of cases of specific illness within days, and here is we have we measure time. So as of about analytical prediction, we can use, as I already mentioned, forecast function or something like this one. Let me make the assessment about future for this next few days with function like we have forecast TTS. So here is I observe from time to time inclination, declination in our data set. So I estimate that this might be some seasonal trend. So I will use forecast function, and here is will be my target dates next series, and I have to use value, it's my observation. Then my timeline, it's interval between observations. So here is not exact dates, just intervals between observation. And I assume that it might be seasonal, some seasonal effect in my data. And let me provide this assessment. So here is I have my prediction about possible cases next 3 days. Analytically, exactly with a linear-based model with additional identification of seasonal trend. And let me do it in another way by using a scatter plot, and let me draw scatter plot. This time I can use even smooth line or just data points, and I can add multiplying trend lines. So here is a trend line. For example, let me do it with linear. Next 3 day, display equation and square value. So here is I have one way to predict possible future development. Let's do it with second order polynomial. And here is I have one possible result. Second possible result, in fact. And here is one more. Order 3. In all this case, you can see in this specific case, our reliability relatively low. It's very closely to 0, so it's unlikely about this model will have behavior in this exact way, but all this provide relatively, it's definitely because of significant outbreak, which is visible in this chart. But anyway, we have general direction and we expect future value in this particular order, which is again very similar to a given area, given value. Here again, it's all about this. Okay, let's back to continue. And last point related to lecture 4, it's transportation, transshipment, and a segment model, which is part of general optimal management problem-solving task. So, in fact, transportation model allows distribution goods from several points of supply to numbers of points of demand, and the resource in vein optimally allocated using involved given capacity of goods and each source and given requirements of goods. And most common objective transportation problem is to schedule shipment from source destination that total production transportation could be minimized. In fact, this kind of task not only related to goods transportation, but similar or very like a problem which is have strict relationship with transportation problem is a segment problem, which is specific class also of linear, so-called linear programming problems that involve determination of most efficient the segment of peoples to projects, sales to territories, contacts to buyers, etc., etc. So actually, a segment problem it's much more widely used in its covered number of tasks, even up to, for example, creating network grids for mobile communication or creating various schedule of working at different facilities up to educational facilities. Schedule in question, it's actually fall under a segment problem. So it could be solved with this method called linear programming, which in fact has nothing with computer development, but it's methodology of solving of system of linear equations. So here is given insight that scientifically, this both transportation and a segment problem being treated and considered as system as scientifically as system of linear equations. And if you talk about other applications, there is plenty of application which is related to this methodology within different areas. With practice, with electronics, chemicals, not only with marketing. So it's very, very widely used class of technical problems. But right now, technical, social, economical problems, but right now we consider only some essence of mathematical model which is lie behind transportation problem. So if you will just consider conventional transportation problem, which is related to delivering goods, we can depict it mathematically, like giving m sources, and each item source has supply capacity of S of I, then which has to be items delivered to end destination, and demand of destination and of G is it's D from G, and we are going to minimize shipping cost between each source destination given and predefined. For sure, we have advanced version with transshipment problem where multiply chains considered, but okay, your goal will be much more simpler, just understand some assets. So here is given example, like let's say delivering some drugs, medicine from factories or warehouses to, from factories to warehouses, or from warehouses to drugstores or pharmacy shops. It's actually not critically matter. We have resources, we have this, we have capacities at resources at source point, we have requests from destinations, we are given shipping cost, and we have a label multiply shipping routes. So actually answer of transportation problem, it's some shipping plan which will depict amount of items have to be delivered from specific source point to specific destination. And linear programming model has constraints for supply at each source and demand for each destination. Constraints are equivalents in balanced transportation problem where supply equals demand, supply equals to request to demand, and constraints contain inequalities in imbalanced methods where supply does not equal to demand. So at least here you have to understand that we have at least three cases, balanced problem when we have equivalence, and 2 cases for unbalanced problem. In fact, mathematical methodologies almost entirely developed for closed balanced transportation problem when supply equals to resource equal to requests, supply equal demand. So more or test, we have to make some assumption which bring for us unbalanced problem to make it balanced, and then make necessary adjustments. So here is how we can depict balanced problem, equivalation between resource and request, source and demands. And in this case, our objective will be minimize total shipping cost, which will represent number of units shipped from specific source to destination, factory to warehouse. And here is how we can see from previous example how it could be constructed, this equation. So we have to minimize this equation, found some specific x of EG, which will give for us minimum shipping cost. So, and here is list of limitation or constraints, which is given on depicted by resources and requests. Here is how the view look like. And actually, after that, it's have to be used, for example, few mathematical methods, for example, simplex linear programming method to identify and calculate all this X. Fortunately, we can use, it's actually not very difficult task, but very time consuming. It's need a huge number of time to solve system of linear equation. Fortunately, spreadsheet can help us with tools like Solver, which could be configured to automatically implement simplex linear method, employ it, and got correct solution. So here is given one possible layout when we have to prepare our sources data, shipping cost, which is actually multiplication of two matrices, matrix of shipping delivery cost, sorry, which is multiplication of shipping cost over transportation plan. And here is also depicted constraints like flow in, flow out. And solver can be configured to like substituting of values on the transportation plan. Here is a yellow area. Here is by changing cell, and to looking for minimum value of total shipping cost and adding some limitation. Here is given constraints. This layout allows to us to use like actually single constraint, but also we can use a little bit different layouts. In case of unbalancing problem, for example, if we have total supply exceed total demand, so we can add dummy demand point, which will utilize extra resources for sure with zero transportation cost, because nothing will be actually delivered. In other case, in contrast, if we have lack of resources, that's much more difficult situation to create, to establish balance in our situation, and there is no clear solution. But one of possible way it's introduced dummy resources, which will provide imaginary supply items, again with zero shipping cost, because that's impossible to be delivered. But at least this way also give us ability to unbalance it into balanced problem and employ simplex linear programming method. So for sure, after that, some backward adjustments required because it doesn't have some kind of resources. So there is no chance that it will be delivered. But anyway, it's also a way to do it. And again, we can use a little bit another layout in spreadsheet, which allow for us to determine a lack of resources. Here is we have that we doesn't have enough resource. We did introduce dummy warehouse object with that's imaginary resources is blue cell, and after that we can add that's again dummy row into a layout and adjust our constraints creation. And actually in spreadsheet it will be look like here is I already have this all this necessary calculation. So here is I have my dummy object, And I already have configured a solver, which is actually, in fact, show for me my objective function, which is multiplication of these two matrices. Actually, this filled with 0, it's future transportation plan. Initially, it's empty, and it's objective for evaluation and creation and producing some numbers here. Then we have, it's actually area for changing variables. In this will be changing variables, solver will do it. And here is we have all necessary settings, including one that's our output must be in integer value. We must provide uniform solution in this case. Okay, so once you prepare all this limitation, so the only things you have to do is like save your result, keep your result, and that's all. That's all. So here is for sure Excel proposed kind of transportation plan to deliver necessary goods. For sure we have the only significant issue because there is no these resources, and this particular pharmacy will not, let's say, use this amount of good because it does not exist. Okay, so that's actually almost all I want to talk about to finalize with topic 4 with biostatistics methods. And right now we move into second part of lecture, which is related to information system. Let me start.